Imagine a future where humans no longer just dream about exploring the cosmos, but actually live and thrive among the stars. Picture not just astronauts, but families, scientists, and adventurers, all calling a fully autonomous space station their home. At the heart of this revolutionary leap into the future, we find artificial intelligence, a force capable of transforming science fiction into reality. But how exactly does artificial intelligence shape this new frontier? And what incredible possibilities and formidable challenges does it present as we design the homes of tomorrow in the skies above? Today, we will unravel the fascinating role of artificial intelligence in creating these self-sustaining marvels of human ingenuity. From orchestrating seamless operations to ensuring the safety and comfort of inhabitants, artificial intelligence stands poised to redefine how we engage with the final frontier. So join me as we journey through the transformative power of artificial intelligence in space exploration, beginning with a look back at the remarkable evolution and current state of space station design. Let's take a journey back in time to see how the vision of space stations evolved from mere concepts to tangible marvels orbiting Earth. In the mid-20th century, the space race catalyzed the first serious efforts towards constructing permanent outposts in space. The earliest designs were heavily influenced by a dream of extended human presence beyond our planet, but these visions were bound by the technological constraints of the time. One of the initial concepts conceived in the 1950s was the rotating wheel station, a design that aimed to create artificial gravity by spinning. While never realized, it inspired generations of engineers to think seriously about living in space. Fast forward to 1971, when the Soviet Union launched Salyut-1, the first ever space station. It was a modest beginning, primarily focused on demonstrating that long-term space habitation was possible. However, Salyut-1 was largely dependent on human input. Every maneuver, system check, and maintenance task relied on cosmonauts and ground control, making operations labor-intensive and limited in scope. Then came the era of space stations that many are familiar with today, like Mir and the International Space Station, commonly known as the ISS. These structures represented monumental steps forward. Mir, launched in 1986 by the Soviet Union, was the first modular station, allowing for expansion and a variety of scientific experiments. Yet, its systems were still largely controlled by humans. The astronauts on board acted as hands-on operators, manually conducting scientific experiments and managing vital life support systems under the watchful eyes of mission control back on Earth. The ISS, a marvel of international cooperation, expanded upon Mir's foundations. Since its first component was launched in 1998, it has become a hub of scientific research, hosting various international astronauts. The station incorporates some automatic systems, but human oversight remains essential. Crew members routinely engage in maintenance tasks and adjustments, and mission control teams are always on standby to troubleshoot problems. While these stations allowed for prolonged human presence in space, they also highlighted the limitations of relying heavily on manual control and human oversight. It's here that the conversation about automation and artificial intelligence begins to take center stage. As we strive for longer, more sustainable missions, the need for a shift towards autonomous operations becomes apparent. The idea is not just to support humans as they live and work in space, but to create an ecosystem where space stations can function with minimal human intervention. This entails employing artificial intelligence to manage routine operations, optimize resource use, and even conduct repairs autonomously. The promise of artificial intelligence lies in its ability to enhance the capabilities of space stations, paving the way for self-sufficiency. Imagine a future station where artificial intelligence can predict equipment failures before they happen, or adjust atmospheric conditions in response to the needs of the crew without waiting for human input. These advancements could free up astronauts to focus more on exploration and scientific discovery rather than maintenance. However, the transition to artificial intelligence-driven operations isn't without challenges. The current human-dependent model of space stations means that we must first overcome significant technological hurdles, such as ensuring the reliability and safety of autonomous systems in the harsh environment of space. Moreover, developing complex algorithms that can handle the dynamic and unpredictable nature of space requires substantial investment and innovation. As we move forward, understanding these challenges and harnessing the potential of artificial intelligence will be crucial for the future of space exploration. This shift represents a significant paradigm change from merely living in space to thriving, with space stations evolving from human-reliant platforms to independent, life-sustaining entities. Let us now explore the exciting possibilities that this transition might bring to the forefront of our interstellar ambitions. Consider the process of designing a space station, a task so complex it requires the best minds in architecture, engineering, and technology. Now imagine artificial intelligence stepping into this role, not just as a tool, but as the architect orchestrating every detail of the design. This transition is more than a technological advancement. It's a revolution in how we conceptualize and create our future homes in space. At the heart of this innovation lie AI algorithms, which are crafted to handle the nuances and challenges of designing structures meant to operate in environments vastly different from Earth. These algorithms are capable of processing vast amounts of data, running countless simulations to determine the most effective and efficient designs. Picture a design team where an AI acts as the lead architect, using its computational power to create blueprints that optimize every square foot of space. This is crucial when you consider the constraints of a space station, where every inch counts and every resource must be meticulously managed. Experts in the field highlight AI's unparalleled ability to innovate beyond human limitations. While traditional methods rely on trial and error, AI can foresee potential issues, test multiple configurations, and suggest improvements all before a single component is built. It's like having a visionary designer who can predict how every change will play out over time, adjusting blueprints instantaneously based on environmental factors and mission needs. This capability doesn't just enhance efficiency, it transforms planning from a static to a dynamic process. For instance, consider the task of optimizing space utilization within a station. AI can simulate human and robotic movement patterns, predict traffic flow, and tailor layouts to ensure safety and efficiency. Whether it's determining the placement of research labs, living quarters, or storage areas, AI can create spaces that are not just functional but adaptable. It can factor in the varying needs of different crew members or shifts in research focus, ensuring every design remains flexible and responsive. Furthermore, resource management, a critical aspect of space station sustainability, is another area where AI shines. By running advanced simulations, AI can predict resource consumption patterns and suggest designs that minimize waste and maximize efficiency. Imagine an AI that can simulate the entire life cycle of a resource, from storage and consumption to recycling, ensuring that every drop of water, every watt of power is used wisely. To illustrate AI's architectural prowess, let's look at some AI-designed models and simulations. Prominent AI projects have already developed conceptual models for habitats that incorporate natural light distribution, temperature regulation, and even psychological well-being into their designs. These models often utilize biomimicry, drawing inspiration from natural ecosystems to create environments that support life sustainably. However, the journey doesn't stop with design. From these blueprints, AI moves into the realms of engineering and construction, where it plays a pivotal role in turning concepts into reality. It's not just about drawing up plans and leaving the rest to human engineers. AI continues to guide the process, optimizing construction methods, selecting materials, and even developing robotic systems that carry out the physical task of building. As we transition from the architectural prowess of AI to its role in engineering and construction, we see a seamless handoff from digital design to physical creation. This integration ensures that space stations of the future are not only well conceived, but are also built efficiently and sustainably, setting the stage for an era where human ingenuity and artificial intelligence work hand in hand to explore the stars. This promises to redefine both our capabilities and ambitions in space exploration, making the unimaginable not just possible, but potentially within reach in our lifetimes. As we delve into the engineering and construction phases of space station design, it's important to recognize the transformative role that artificial intelligence plays. While the design phase showcases AI as an innovative architect, the engineering and construction phases reveal it as a master builder. Here, AI-driven robotics and automation take center stage, not only streamlining the construction process but also ensuring unparalleled precision and safety, essential in the unforgiving environment of space. One of the most remarkable capabilities of AI in construction is its use of robotics to perform tasks that would be perilous or impossible for humans. In space where conditions are extreme and the stakes are high, robotics can carry out complex activities with a level of accuracy that minimizes human risk and maximizes efficiency. These AI-driven robots are adept at assembling modules, welding components, and even conducting repairs, tasks that traditionally required extensive human involvement. By automating these processes, AI reduces the time and cost associated with construction while maintaining a focus on safety and reliability. Experts in space engineering emphasize the importance of AI's predictive analytics, which are crucial in foreseeing and mitigating structural challenges. For instance, AI can evaluate potential stress points in a design, simulate environmental conditions such as radiation exposure or micrometeorite impacts, and propose adjustments before construction begins. This level of foresight ensures that structural integrity is maintained, safeguarding both the space station and its inhabitants. One illustrative case study of AI's application in space engineering is its use in the construction of satellite networks. NASA and private companies like SpaceX have been deploying swarms of satellites to create global communication networks. AI plays a key role in coordinating the precise positioning of these satellites, calculating optimal orbits, and managing the construction of supporting ground infrastructure. This level of coordination is essential to maintain functionality and avoid collisions, highlighting AI's capability in managing complex systems. Another successful application is in the development of autonomous construction technologies for lunar bases. The European Space Agency has experimented with AI-controlled 3D printers that use lunar regolith, the moon's soil, as building material. These printers, guided by AI, can construct habitats layer by layer, ensuring that structures are both strong and resource efficient. This method reduces the need to transport building materials from Earth, lowering costs and emissions. The ability to use local resources exemplifies AI's potential to enable sustainable living in space. Looking forward, as we transition into discussing AI's role in operational and environmental management, it's clear that the integration of AI in engineering and construction not only enhances the feasibility of building in space, but also sets the foundation for maintaining these structures once they are operational. AI systems will continue to monitor structural health in real time, predict necessary maintenance, and manage resources efficiently. This ongoing involvement ensures that space stations remain safe and capable environments for humans and robots alike. In essence, AI's contribution to engineering and construction phases is profound, marrying precision with innovation. It allows us to push the boundaries of what is possible, creating space stations that are not only futuristic in design but also revolutionary in their execution. With AI's aid, we're not just building structures in space, we're constructing the future of human habitation among the stars, laying down pathways to previously unimagined possibilities. As we explore further, AI's ability to oversee the continual operation and manage the environmental conditions of these space stations will become increasingly pivotal, ensuring they are not just places to visit, but places where humanity can live, work, and thrive. In the quest to create fully autonomous space stations, achieving operational efficiency through artificial intelligence is a game changer. At the core of this efficiency lies AI's ability to monitor and manage complex systems continuously, ensuring that everything runs smoothly without constant human intervention. This includes the critical functions of life support systems, energy distribution, and communications, all of which are vital for the safety and comfort of inhabitants. Take life support systems, for example. These systems maintain crucial elements such as air quality, water supply, and temperature control. AI steps in as a vigilant guardian, constantly analyzing data to detect any deviations from normal conditions and making real-time adjustments to ensure optimal living standards. For instance, AI algorithms can predict fluctuations in carbon dioxide levels and automatically adjust ventilation systems to maintain safe and comfortable environments. This predictive capability not only ensures residents' well-being but also reduces energy consumption, as systems are fine-tuned to operate only when necessary. Energy distribution is another area where AI significantly enhances efficiency. In space, every watt counts, and AI excels at managing energy resources meticulously. By observing patterns in energy consumption, AI can efficiently allocate power to different systems, prioritizing essential functions while minimizing waste. This might involve harnessing renewable energy sources like solar panels and using AI to decide when to store energy or redistribute it across different operational needs. This strategic management ensures that power is always available for critical operations without unnecessary expenditure, thereby extending the station's operational life. Communications in space rely heavily on maintaining uninterrupted links between the station and Earth, as well as among various onboard systems. AI facilitates seamless communication by managing data traffic and optimizing bandwidth usage. It can reroute signals in case of disruptions, ensuring that vital information always reaches its destination without delay. This is especially important for research activities and mission-critical updates that require precise timing and accuracy. AI-driven maintenance protocols further bolster operational efficiency by maintaining the station's longevity and functionality. Unlike traditional systems that rely on regular human checks, AI can continuously monitor equipment health, identifying signs of wear and tear before they result in failures. This proactive maintenance approach extends the life of the station's infrastructure and reduces downtime. For example, sensors embedded in machinery can feed real-time data to AI systems, which use predictive analytics to determine the likelihood of component failures and schedule maintenance before issues arise. This reduces costs and prevents unexpected disruptions to operations. Industry insights highlight the role of AI's predictive analytics in sustaining operational stability. By analyzing historical and real-time data, AI can anticipate future conditions and make informed decisions to maintain smooth operations. This includes predicting changes in environmental conditions and adjusting system operations accordingly, or forecasting resource depletion and optimizing usage to prevent shortages. These advanced analytics provide a robust framework for decision-making that underpins the station's continuous and efficient function. As we move from discussing operational efficiency to the broader theme of sustainable resource management, it's clear that AI's capabilities extend beyond mere functionality. AI not only ensures that systems operate efficiently, but also contributes to the sustainability of resources crucial for long-term habitation. By fine-tuning resource usage and enhancing system performance, AI supports the goal of creating self-sufficient environments in space. In summary, AI plays an integral role in enhancing the operational efficiency of autonomous space stations, ensuring that they run smoothly, sustainably, and safely. From managing life support systems to overseeing energy distribution and communications, AI acts as an intelligent overseer, constantly optimizing operations for the best outcomes. As we explore further, AI's role in sustainable resource management will become even more essential, paving the way for human habitation that's not just possible but sustainable. In the extraordinary environment of space, sustainability isn't just a goal, it's a necessity. Space stations must function as closed-loop systems, where every resource is carefully managed and recycled. This is where artificial intelligence showcases its remarkable ability to oversee sustainable resource management, transforming how we live beyond Earth. Artificial intelligence excels in creating efficient recycling processes crucial for closed-loop ecosystems. It can manage waste streams with precision, identifying and separating materials for reuse or repurposing. Imagine an AI system that monitors every piece of waste generated on a space station, from food scraps to broken equipment, and then categorizes it for efficient recycling. Systems can automatically sort recyclables, compost organic waste, and potentially convert non-recyclables into reusable materials through advanced processes like pyrolysis, which AI could manage optimally. Consider water recycling, an area where AI's impact is particularly profound. Water is heavy and expensive to transport from Earth, so recycling is vital. AI can manage sophisticated water reclamation systems, analyzing data on water quality and adjusting purification processes as needed. By doing so, it ensures a constant supply of clean, potable water, minimizing waste and conserving this precious resource. Real-time monitoring allows AI to detect any anomalies such as contamination and initiate corrective actions more swiftly than human operators might. Energy resources, too, benefit from AI's management capabilities. AI can balance energy production and consumption, particularly from renewable sources like solar power. By forecasting energy demands and scheduling battery storage and distribution, AI ensures that no energy is wasted and that essential functions always have the power they need. For instance, during periods of low demand, AI could divert excess energy to power energy-intensive processes like water electrolysis, which breaks down water into oxygen and hydrogen, essential for life support and fuel, respectively. AI's role extends to optimizing all resource allocations across the station. By analyzing vast streams of data, AI algorithms can forecast resource shortages or surpluses and adjust consumption accordingly. This might involve rationing supplies during times of scarcity or shifting resources to critical areas during emergencies. Such precise management extends the station's capability to support its crew over long durations, essential for missions that stretch weeks, months, or even years. Experts in space exploration are optimistic about the potential of AI to drive long-term sustainability. They highlight AI's ability to adapt its algorithms based on machine learning from past data, allowing the systems to improve over time and thus become even more efficient. This adaptability is crucial in the unpredictable environments of space where conditions can change rapidly. Despite its promising capabilities, the implementation of AI in sustainable resource management is not without challenges and ethical considerations. For instance, the reliance on AI for essential functions raises questions about autonomy and control, especially if critical decisions need to be made swiftly. There's also the concern of ensuring data integrity and cybersecurity to prevent breaches that could disrupt operations. Striking a balance between human oversight and AI autonomy is crucial to address these issues. As we transition into exploring these challenges and ethical considerations, it is clear that the promise of AI in managing resources sustainably is vast and transformative. By optimizing resource allocation, enhancing recycling, and reducing waste, AI not only ensures the viability of long-term space habitation, but also serves as a testbed for sustainable technologies that could have profound implications on Earth. The way we harness AI today may well set the foundation for humanity's sustainable future, both on our home planet and beyond. As we delve into the complexities and ethical dimensions of integrating AI in space operations, it is important to consider how these lessons might inform our ongoing relationship with technology and nature. Embracing artificial intelligence for the development of fully autonomous space stations opens up a world of possibilities, but also presents a set of unique challenges and ethical considerations. As we forge ahead with this technology, it's crucial to navigate the complexities associated with AI decision-making, autonomy, accountability, and the balance between machine control and human oversight. First, let's talk about the technical challenges. AI systems designed for space must function flawlessly in an environment that is harsh and unpredictable. They need to be resilient to technical failures and capable of adapting to unexpected conditions, such as sudden solar radiation spikes or equipment malfunctions. Developing AI that can handle such complexities with little to no input from Earth requires cutting-edge advances in machine learning and robotics. Moreover, the need for robust cybersecurity cannot be overstated. Protecting these autonomous systems from hacking or unauthorized access is vital, as any breach could lead to disastrous outcomes. However, it's not just about technical hurdles. Ethical considerations play a significant role. When we grant AI the autonomy to make decisions that affect life support systems, resource management, and overall station operations, questions arise about who holds accountability when things go wrong. If an AI system fails, results in losses, or makes a decision that leads to unforeseen consequences, such as prioritizing resources incorrectly, who is responsible? The engineers who coded the AI, the organization operating the space station, or the AI itself? This brings us to the crux of one of the central ethical issues: decision-making autonomy. AI may be programmed to act independently, but should it be empowered to make life or death decisions without human intervention? For instance, in the event of a critical systems failure, should AI have the authority to decide on prioritizing crew evacuation or resource allocation? Or should a human always be in the loop, even if it means potential delays in action? Balancing AI control with human oversight is essential to address these concerns. Experts suggest a hybrid approach where AI handles routine tasks and emergencies with predefined protocols, while humans remain in charge of strategic decisions and ethical dilemmas. This model ensures that while AI maximizes efficiency and safety, ultimate accountability and critical decision-making remain human responsibilities. Expert perspectives often emphasize the importance of setting up transparent AI systems. Transparency entails making AI decision-making processes understandable and auditable, so humans can trace the logic behind AI actions and decisions. Such transparency is crucial for building trust in AI systems, especially in environments where human lives are at stake. Moreover, managing AI-driven risks involves rigorous testing and simulation of potential scenarios to identify vulnerabilities and refine AI responses. It is vital to develop comprehensive protocols and guidelines that govern AI behavior, ensuring it aligns with ethical standards and mission objectives. Looking ahead, it is clear that the journey of integrating AI into space exploration is ongoing. Anticipating future trends, we might see the establishment of international regulatory frameworks that oversee AI use in space, promoting ethical practices and collaborative research. As AI continues to evolve, it could lead to new ways of cooperation between machines and humans, each complementing the other's strengths. As we progress, the lessons learned in managing AI in the cosmos will undoubtedly influence how we approach AI ethics and governance on Earth. By addressing these challenges head-on, we pave the way for a future where AI not only supports human exploration and habitation of space, but also contributes to a sustainable and equitable technological landscape back home. Transitioning to the next phase of our exploration, these considerations will guide us in foreseeing the exciting developments that await in the realm of AI-driven advancements in space exploration. As we step into the future of artificial intelligence and space station technology, the possibilities truly become limitless. Emerging trends suggest even more sophisticated AI systems will revolutionize how autonomous space stations operate, offering capabilities that not only enhance autonomy but also redefine our approach to space exploration. One of the most exciting advancements is the integration of quantum computing with AI. Quantum computing holds the potential to exponentially increase the processing power available to AI systems. This would allow AI to handle incredibly complex calculations and data analyses at unprecedented speeds, making real-time decision-making even more precise and informed. For instance, quantum-enhanced AI could rapidly simulate and optimize thousands of scenarios to identify the most efficient path for resource management or emergency response, enhancing the station's resilience and adaptability. Moreover, the rise of the Internet of Things, or IoT, extends AI's reach by interconnecting various devices and sensors within the space station ecosystem. When integrated with AI, IoT enables a seamless exchange of data across millions of sensors, allowing for real-time monitoring of every aspect of the station. This interconnected environment creates a cohesive system where AI can predict maintenance needs, enhance energy efficiency, or even ensure the crew's health and safety by monitoring environmental factors such as radiation levels and air quality. Visionary forecasts suggest that AI will play an essential role in the establishment and management of interplanetary space stations. Imagine an AI system sophisticated enough to independently manage a network of stations on the Moon, Mars, or even beyond. These AI systems would not only maintain the infrastructure but also facilitate the rapid deployment of new stations, enabling humanity to expand its presence across the solar system. They could autonomously manage complex tasks like terraforming, resource extraction, and habitat construction, making interplanetary colonization feasible and sustainable. As we envision these future possibilities, it's crucial to explore the practical applications and the impacts these advancements will have on Earth and beyond. The developments in AI and space technology have profound implications for industries across the globe. For instance, advancements in AI-driven resource management could lead to more sustainable practices in agriculture, energy, and waste management on Earth. The AI tools developed for closed-loop systems in space can be adapted to improve recycling and resource efficiency on our planet, contributing to environmental conservation efforts. AI's role in space exploration also promises to inspire breakthroughs in robotics and remote operations. The technologies developed to maintain space stations could be applied to remote or hazardous environments on Earth, revolutionizing industries such as mining, oil exploration, and disaster response. AI's ability to monitor environments and predict failures can lead to safer and more efficient operations, ultimately saving lives and reducing environmental impact. Furthermore, the collaboration between AI and quantum computing might lead to advances in fields such as medicine, finance, and climate science. The enhanced analytical capabilities could enable breakthroughs in disease treatment, optimize financial models, or improve climate change models, offering insights that were previously unattainable. In summary, the future of AI in space station technology is not just about enhancing autonomous capabilities, but also about creating a symbiotic relationship between space innovation and earthly applications. The ongoing advancements promise to push the boundaries of what we can achieve, fostering a future where technology seamlessly integrates with human endeavors to explore and sustain life beyond our home planet. As we continue to explore these synergistic possibilities, it's evident that AI will play a pivotal role in shaping the future of space exploration, making the dream of interplanetary living a reality and bringing forth transformative solutions that benefit humanity at large. As we envision the impact of artificial intelligence-driven autonomous space stations, the first aspect that stands out is their potential for practical applications that can significantly benefit life on Earth. These space stations, equipped with cutting-edge AI technologies, are not just about exploring new frontiers in the cosmos. They also offer solutions to some of the pressing challenges we face on our home planet. One of the most promising applications comes in the form of advancements in remote medical assistance. In environments where immediate medical help is unavailable, such as remote Earth locations or during long-duration space missions, AI can play a crucial role. By integrating AI into space stations, we can develop sophisticated remote medical systems capable of diagnosing and even treating a variety of conditions autonomously. For instance, AI can analyze medical data from wearable health devices in real time, providing instant feedback and recommendations for treatment. Imagine a future where people in rural or underserved areas have access to AI-driven health diagnostics, improving healthcare outcomes and accessibility worldwide. Environmental monitoring is another domain where AI-enabled space stations can offer profound benefits. As Earth's climate undergoes significant changes, monitoring environmental conditions becomes paramount. AI-equipped satellites and space stations can continuously analyze data related to air and water quality, deforestation, ocean health, and more. This information can be used to create detailed maps and models that help scientists and policymakers make informed decisions about climate action and conservation efforts. Consider a case where AI predicts adverse weather patterns or detects pollution levels rising in a specific area, allowing for preemptive measures that can mitigate damage to ecosystems and human populations. To illustrate these possibilities, let's explore a hypothetical scenario. An AI-managed space station monitors Earth's vital signs, providing early warnings for natural disasters such as hurricanes, floods, and wildfires. This system doesn't just alert authorities, it coordinates with Earth-based AI systems to optimize emergency responses, strategically deploying resources where they are needed most. Such synergy highlights how space technology can become a global security net, enhancing resilience against natural calamities. Beyond these immediate applications, AI-driven space stations also hold long-term implications for human exploration and settlement in space. By ensuring autonomous station operations, AI reduces the need for constant human presence, minimizing risks and costs associated with space travel. This autonomy facilitates the establishment of more permanent outposts on the Moon or Mars, paving the way for sustainable human settlement. AI systems can manage essential life support operations, resource utilization, and even habitat expansion, making long-duration missions viable and safe for humans. Furthermore, the data and experiences gained from operating these autonomous systems in space feed back into our Earth-based technologies, fostering advancement in robotics, AI, and sustainable resource management. The closed-loop systems designed for space habitations can be adapted for Earth applications, enhancing urban living through more efficient waste management and energy use. As we look to the future, the broader impact of AI-designed space stations becomes increasingly significant. They represent a paradigm shift in space exploration, where human ingenuity and AI's capabilities converge to overcome the challenges of living beyond Earth. These stations not only advance our understanding of the universe, but also inspire technologies that improve life on our planet. In conclusion, AI-driven autonomous space stations offer a glimpse into a future where technology serves humanity both in space and on Earth. From enhancing remote medical care to pioneering environmental monitoring systems, these advancements promise to tackle some of the most urgent global issues. They stand as a testament to human creativity and determination, driving us to explore the stars while preserving our world. The journey of AI in space continues to unfold, setting the stage for a future rich with possibilities and transformative change. As we draw our exploration to a close, let's take a moment to reflect on the pivotal role that artificial intelligence plays in the development of fully autonomous space stations. This journey has unveiled how AI is revolutionizing space exploration and paving the way for a future where humanity can seamlessly extend its reach beyond Earth. Throughout the video, we've delved into how AI acts as the master architect, designing intricate blueprints that optimize every inch of space for functionality and adaptability. From transforming conceptual ideas into feasible architectural plans, AI ensures that these space habitats are not only efficient but also sustainable. We've seen how it orchestrates the construction process with precision and safety, employing robotics to undertake tasks that would be challenging for human hands alone. This advancement is critical, as space stations must function in environments where human intervention is limited or even impossible. AI's role doesn't stop at construction. It continues as a vigilant overseer, managing the station's operations with unmatched efficiency. By handling life's essential systems from air and water purification to energy distribution, AI enables space stations to become self-sufficient entities. Its predictive analytics capabilities ensure resource conservation, minimizing waste and optimizing supply chains in real time. This level of autonomy is crucial for the success of long-duration missions and eventual human settlement on other celestial bodies. Importantly, we've also discussed how AI's impact goes beyond space exploration, influencing Earth-bound applications. The technologies and insights gained from AI in space are directly applicable to solving some of Earth's most pressing challenges, such as environmental monitoring and sustainable resource management. AI's ability to synthesize large data sets and predict future trends can help us mitigate climate change, improve healthcare access, and enhance disaster response strategies. Reflecting on these insights, it's clear that AI is not just a tool but a transformative force in redefining our approach to the cosmos. It empowers humanity to contemplate and actualize the dream of becoming a multi-planetary species. This technological leap holds the potential to foster international collaboration, drive scientific discovery, and inspire future generations to reach for the stars. As we contemplate the broader implications of these advances, consider the words of Carl Sagan, who famously said, "Somewhere, something incredible is waiting to be known." AI is our gateway to discovering that incredible unknown, propelling us into new frontiers of exploration and understanding. We invite you to ponder these possibilities and share your thoughts on how AI might continue to shape our destiny in space. Your engagement is vital in cultivating a community of thinkers and explorers. Subscribe to our channel for more captivating insights into futuristic technology as we continue to explore the remarkable journey of innovation that awaits us. Together, let's embrace the future with curiosity and courage as we stand on the brink of a new era in space exploration.